Hey guys, welcome to GER Mathematics and Statistics lesson. In today's video, we are going to continue where we stopped in our last discussion on the topic binary operations. We are going to be discussing the associative property. If you haven't subscribed to this channel, please click the subscription button below, subscribe to the channel and smash a like on this video, and I will be seeing you in this class. Welcome back. We are going to be talking about associative property in this class. An associative property under the topic binary operations. Okay? Now, in our last video, we talked about closure property. We talked about the commutative property of the binary operation. And I told you in that video that the commutative property belongs to the binary operation defined on a set that is non-empty and is closed. In this case, we are going to be talking about another property that belongs to the binary operation. So, associative property is for the binary operation, not for the non-empty set. So, the proper statement to make is, when is a binary operation associative defined on a non-empty set that is closed? So, we are going to define that property and take a few examples to explain the property. So, come with me. Now, let's start with defining or giving an explanation to the associative property. So, a binary operation asterisk, a binary operation denoted by asterisk, is said to be associative when defined on a closed non-empty set, if and only if for all A, B, and C elements in the non-empty set S, A asterisk B asterisk C is equal to A asterisk B in bracket asterisk C. So this property, for any three elements selected randomly from a non-empty set S in this case, if it holds, then it implies that asterisk binary operation in question is associative. So the associative property for a binary operation tells us that when a binary operation asterisk that is defined on a non-empty set that is closed is associative, then any three randomly selected elements from the non-empty set S will obey this condition. Now, let's take an example to show you how to test if a binary operation is associative. So I'm going to start with an example here. I'm going to call this example 1 in this particular lesson. So let us look at this question. A binary operation asterisk is defined on a closed non-empty set S by A asterisk B equals A plus B in bracket all over 2 minus C. So this problem talks about a binary operation defined on a closed non-empty set that is defined by this, in which case A, B, and C are members of the non-empty set. So what we want to do is asterisk associative. So we want to test if asterisk, the binary operation, is associative. And let me put it precisely, is asterisk associative on S? So we want to see if asterisk is associative on this set. Okay? So come with me. Is asterisk associative on this set S? So let's see how that is done. So I'm going to come here with a solution to the problem. And for us to start solving this problem, we have to recall the condition that makes the binary operation asterisk in this case, associative on a non-empty set. So I'm going to start with stating that if asterisk is associative on S, then the condition earlier stated means that A asterisk B asterisk C must be equal to A asterisk B asterisk C in that order. So I'm going to start this clearly. I'm going to have to pick one side. So this is my left hand side and this is my right hand side of the equation. So what you are going to start to do is taking one side, operating on it, and then taking the other side, operating on it, and thereafter comparing both results if they are equal. If both results are equal, then you can conclude that asterisk is associative. If both results from both sides of the equation are not equal, then you have to conclude that asterisk is not associative as defined by this. Okay? So let's start with the left hand side. I'm going to start with the left hand side. So I'm going to say from the left hand side, A asterisk in bracket B asterisk C will be equal to, now I'm going to do this. Let us call what A asterisk in bracket B asterisk C equals unknown. Let's call that an unknown. So I'm using the question mark there because we don't know the result. So I'm going to say something here. Let K be equal to B asterisk C. Let K be equal to B asterisk C. If K represents B asterisk C, then the implication is that A asterisk B asterisk C is equal to A asterisk K. Okay? Did you get that? Now, if that is the case, then, but what is A asterisk K? Come over here. Let's see again how the binary operation was defined. A asterisk B, a thing asterisk the second thing implies the first plus the second minus, oh, I'm going to call this, let me call this, I'm removing C here, and I'm going to call it, let me call this 3, okay? So that it doesn't confuse you. So I'm going to call this A plus B over 2 minus 3. So when you have A asterisk B, the result will give you A plus B divided by 2 minus 3. In other words, first asterisk second is first plus second over 2 minus 3. Let's bring that over here. So A asterisk K, by that definition, will be A is first, so it comes here. K is second, so it comes here. So first plus second divided by 2 minus 3. What have I just done? I've just used the definition of the binary operation to operate on A and K. Okay? Now, having done that, let's bring the problem over here. Let's bring the problem over here. So, having done that over there, let's continue the problem here. Now, I'm bringing it here. This is where we stop. A asterisk K equals A plus K over 2 minus 3. And that's our result for A asterisk K. But again, K was used to represent A, B asterisk C. We had earlier used K to represent B asterisk C. Therefore, putting B asterisk C in place of K here would now give us A asterisk K, which is equal to A asterisk in bracket B asterisk C, will now be equal to, I'm now changing my bracket from being a normal parenthesis to a square bracket. So I'm going to put here A plus in bracket B asterisk C, close bracket, all over 2 minus 3. Now, simplifying this result gives us this. So what am I going to do here? This is A plus, instead of B asterisk C, I'm going to define B asterisk C using what we've been given here also. Now, take note, A asterisk B is A plus B over 2 minus 3. First asterisk second is first plus second over 2 minus 3. So, using that idea of first asterisk second here, this will be first asterisk second gives us first plus second, which is b plus c all over 2, then minus 3. All over the 2 here, and then minus 3. Okay? Now, if you got that, let's come over here and continue the problem. Let's come over here and continue the problem. So, what we are going to have here, if we simplify that result, will be, in the numerator, we would have a plus b plus c over 2 minus 3. All over 2 minus 3. So I want to simplify what is in the square bracket by taking LCM. Clearly, this is over 1, this is over 1, so the LCM is 2. If you take the LCM of 1, 2, and 2, the LCM clearly is 2. Okay? Now, 1 in 2 gives you 2. 2 times A is 2A plus 2 in 2 gives you 1. 1 times B plus C is B plus C plus, or rather minus. 1 in 2 is 2. 2 times minus 3 will give you minus 6. And all this over 2 minus 3. Now, if you come over here again, because this is you dividing a fraction by this number here, that will be this divided by 2, giving you 2a plus b plus c minus 6 all over 2 times 2, in which case you have 4, and this will be 3. Okay? So, this can be called a final result. In my own case, this can be called a final result for what? This can be called a final result for A asterisk B asterisk C. Now, what have we been able to do? So far, so good. We've been able to get the left-hand side. What have we got on the left-hand side? A asterisk in bracket B asterisk C to be. We've gotten it to be 2A plus B plus C minus 6 all over 4 minus 3. Okay? So, what do we do next? We are going to come over to the right hand side. So I'm going to clean this off. Let's come over to the right hand side. Let's test the right hand side to see if the right hand side will give us the same result as we've obtained for the left hand side. So what are we going to do here? Now, I'm going to say from the right hand side, okay? So, from the right hand side, okay? Now, what do we do from the right hand side? I'm going to write out the expression A asterisk B in bracket asterisk C. Now, by the definition, A asterisk B can be called, so I'm going to call this an unknown. A asterisk B, I'm going to say let A asterisk B be equal to, let this be equal to J, okay? So I'm going to use J to represent A asterisk B. And that would imply that J, A asterisk B in bracket asterisk C will be equal to J asterisk C. Did you get that? Okay? Now, if that is the case, then we are going to come over here. But what is J asterisk C? J asterisk C, according to that definition, will be first plus second all over 2 minus 3. That will be the result for J asterisk C. Also, having gotten this result for J asterisk C, J asterisk, what do you call it? So this is J asterisk C. If you now bring J asterisk C, which is equal to the same thing as A asterisk B in bracket asterisk C. If you bring that out, you will now have this. What is J? J is A asterisk B. So I'm going to bring A asterisk B here plus C. So I'm using A asterisk B to represent J now. And all this over 2 minus 3. So let us go further. What is A asterisk B by that definition? It will be first plus second all over 2. Okay? Plus C. And that will be plus C. Before plus C, I think in that definition it was A plus B. This was A plus B all over 2 minus 3. And my plus C comes over here. Okay? So that is what you are going to have. That is what you are going to have. And all this over 2. And then finally minus 3. So that's what you are going to have over here. So let's continue the problem over here. Now, having done that, We are going to come over here to simplify. Remember, for asterisk to be associative, then both sides of the equation, the left-hand side will be equal to the right-hand side. Now, this is the result we've established for the left-hand side. But we are trying to get a result that is equal to this or divergent from this from the right-hand side. Now, so far so good. We have been able to start from here for the right-hand side, denote A asterisk B by J, and represent J asterisk C as the definition demands to be J plus C divided by 2 minus 3. Now, what have we done here? This J asterisk C is the same thing as A asterisk B in bracket asterisk C. So, if A asterisk B asterisk C is demanded, then this J over here will be represented with A asterisk B added to C all over 2. But if you bring in the definition for A asterisk B, what was A asterisk B defined as? It was defined as A plus B all over 2 minus 3. So if you bring in place of A asterisk B, A plus B all over 2 minus 3, then add it to C minus 3 all over 3. That is what you are going to get over here. This should be 2, mind you. So this should be 2. Okay? Now let us simplify that result to see if it will give us the same result as this. Now, so for A asterisk B asterisk C, we now have our final result to be A plus B all over 2 minus 3 close bracket plus C all over 2 minus 3, and that gives you A plus B minus 6. When you take the LCM of 2 and 1, 2 into the LCM will clearly be 2. 2 into 2 is 1. 1 times A plus B will give you A plus B. Then 1 into 2 is 2. 2 times minus 3 will give you minus 6. And you end up having this. You end up having this plus C all over 2 minus 3. Okay? So this gives you A plus B minus 6. Then if you take the LCM of, over here you have 1. So if you take the LCM of 2 and 1, you're going to have 2 again, and that means that C becomes plus 2C all over 2 minus 3. All this over 2. Now finally, if you simplify further, still on this, you are going to end up having the result to be A plus B. I'm bringing my 2C here, plus 2C minus 6 all over. This 2 comes down to multiply this 2 to give you 4 minus 3. Now let's compare the results. You will notice that for the right hand side, I have obtained A plus B plus 2C minus 6 minus 3 all over 4. That is A plus B plus 2C minus 6 all over 4 minus 3. For the left hand side, what did we obtain? We obtained 2A plus B plus C minus 6 all over 4 minus 3. This result we obtained for the left hand side is clearly different from the result we obtained for the right hand side. And what does that mean? The conclusion therefore becomes this. Since left hand side, which was A asterisk in bracket B asterisk C equal 2A plus B plus C minus 6 all over 4 minus 3. Okay? That was the result we obtained for the left hand side. And right hand side equal A asterisk B asterisk C, which was equal to A plus B plus 2C minus 6 all over 4, then minus 3. Then, what does that imply? Left hand side is not equal to right hand side, and asterisk is therefore not commutative. Now, what did we do? All we had to do was to look for an expression for the left hand side, which was A asterisk B asterisk C with B asterisk C in brackets. And we also look for an expression for A asterisk B asterisk C. Okay? Now, what have we done? we have compared the result we obtained for the left-hand side with the result we obtained for the right-hand side to see if both of them are equal. Remember, if both of them are equal, it means that the property of associativity is satisfied, and it tells us that the binary operation is associative. But if we get the results not to be equal, then it means the right-hand side is not equal to the left-hand side, and therefore asterisk is not associative. Okay, so I'm going to take one more example, and we shall call this video, we shall bring this video to a close. Okay, so the second example I want to take is this. Let's take a simple example. Let's asterisk be defined on a closed non-empty set by a closed non-empty set S by A asterisk B equals A plus B. Okay? So let us define asterisk to be this. Okay? Let's define asterisk to be this. A asterisk B means A plus B. Is asterisk associative? Okay? Is asterisk associative on S? Now, solution becomes this. If asterisk is associative, then recall A asterisk B asterisk C must be equal to A asterisk B asterisk C. Now, what is the routine? The routine will take us straight to what we had done earlier on. Let's go back to what we had done earlier on. So, what does the routine demand? We are going to start with the left-hand side. From the left-hand side, A asterisk in bracket B asterisk C is equal to A asterisk B asterisk C would come from this definition. If A asterisk B means A plus B, then B asterisk C should mean B plus C. Now, A asterisk B plus C would now be A plus whatsoever is inside the other way, or the other bracket, B plus C. And that will give us A plus B plus C as the final expression for A asterisk B asterisk C. However, from the right hand side, A asterisk B asterisk C will be equal to A asterisk B, what is in the first component, plus C, what is in the second component by definition. Now, this will result in A asterisk B, which is already A plus B. So I'm going to put this A plus B in bracket plus C. Now, this results in A plus B plus C. Now, you will notice that the result I obtained for A asterisk in bracket B asterisk C is equal to the result I have obtained for A asterisk B in bracket asterisk C. What does that tell us? It tells us that since A asterisk B asterisk C is equal to A asterisk B in bracket asterisk C, then asterisk is associative. Now, in my two examples, I have used asterisk. Please take note, you can use any symbol. Any symbol other than asterisk can be used to represent a binary operation, although in this class and in this video, I have used asterisk in both examples to represent my binary operation. Please go over this video again, watch this video, try to decompose or try to deduce what I've said so far, try to expand on what I've said so far, and I'll be seeing you in the next video. If you haven't subscribed to the channel, please subscribe now by clicking the subscription button below, and make sure you smash the like on the video. Thank you very much.